Okay, so this week we're going to take a look at conic sections. Okay, there are 4 different conic sections. We're only going to be studying 3. There's the circle, the ellipse, the parabola, and the hyperbola. Okay, we've done a lot with circles, earlier in the year and in other areas. So we're going to focus on the ellipse, parabola, and hyperbola. Okay, and what those shapes basically are is they're the different ways you can slice a cone, and you can get those shapes. Okay, so let's start with the circle, the ellipse, and the parabola. If you take a cone, okay, and you cut the end of the cone off, cut it straight across, and then look at the end, the shape you'd have is a circle. It's like a cross section. Now, if you did the same thing, except instead of cutting the cone straight across the top, you cut it at a little bit of an angle, okay, but still going through the sides of the cone. And then you look at the shape, you'd have an oval, or what's called an ellipse, okay, if you cut the cone on a diagonal. Now, if you cut the cone slanted, but you don't go through the side, you go right out through the bottom of it. Okay, if you were to just shave that side right off, the shape you get, it's kind of like a U shape, and that's a parabola. Now, the last shape is the hyperbola. Okay, the hyperbola you can only get by putting 2 cones together, okay, joined at the vertices, and slicing it straight down. Right, if you do that, you get a shape that would look something like this when you look at it from the side. Right, that's the hyperbola. So those are called the conic sections. Those are the 4 conic sections and how you get them by slicing a cone. That's why they're conic sections. Okay, any questions on the 4?
You have to draw that?
Yeah, I would know the 4 basic conic sections. Yep.
I mean, like draw them.
No, you don't have to sketch it. That's just, no. All right, so we're going to focus, the first one is a parabola. So to define the conic section, it's a little tricky sometimes with wording. It's very easy when I show you a picture. But let me give you a simple conic section that you could define with words, a circle. Okay, a circle is basically a collection of points that are all equidistant from the same point. We call that point the center. Okay, that's a circle. It's a collection of points that are all the same distance from one point we call the center. Well, parabola is a little harder to describe. It's a collection of points in the plane, so it's not 3D, it's in a flat plane. So it's a collection of points that are the same distance from 2 things. They're the same distance from a special point that we're going to call F, and from a line that we're going to call D. So if you take any point on your parabola, okay, it doesn't matter where, any point on that curve, and you measure the distance from that point to a special point we're going to call F, and then you measure the distance again from that same point to a special line we're going to call D, those 2 distances will always come out the same. And I'll show you a picture. I'll show you kind of an interactive picture where I can move some things around, and I think it'll make more sense. Okay, that special point F, okay, the reason we named it F is for focus. It's called the focus. And that special line I talked about earlier, D, it's called your directrix. Okay, with conic sections, there's a lot of vocabulary. But we'll try to get through all the vocabulary up front, and then the rest of the class will just be examples. Any question on the definition? So pick any point you want, anywhere on your parabola, measure the distance from that point to your focus, measure the distance from that point to your directrix, and it will always come out the same. It will always be the same. Let me show you an example. So in this example, the line in purple, that's my parabola. I labeled the focus as A, and the directrix is that line that's horizontal, line DE. Right? It's the line y equals 3 in this case. Now, let's see if I can, yep. As I drag B, notice what happens. The distance from B to the focus and B to the directrix always stays the same. Okay? It's always, if you compare those two, oops, I just messed it up. So no matter how you move that point, AB and BC always come out the same.
Don't look the same.
That's because I keep moving. You mean those two distances?
Yeah.
AB and B, they are. They are measured. They're the same. I can. Okay, if you were to, you know what, the easiest way to see it might be to put it right like that.
Oh, yeah.
So AB and BC, they're the exact same distance.
Can you go back close to the other?
Yeah. So any question on the definition now? All right. So anybody know where you've seen parabolas or where they use that kind of shape?
Arch.
Okay, yeah, you might see it in an arch. Okay, maybe for a bridge or an archway you walk through. Could kind of have that shape to it. Anywhere else? You've seen it like the entrance to a tunnel? Yeah, you might see something kind of like that there too. Another place you see it is in a mirror. Okay, some mirrors have that shape. They're called parabolic reflectors. What else? Maybe certain satellite dishes. Like if you look at a satellite dish from the side, kind of has that shape to it. And the advantage, what a parabola does, is if this was a mirror, all the light that bounces into the mirror is all reflected at the same point. Okay, it all goes right to that point. So on a satellite dish, sometimes you see something kind of like this. Here's the side of the satellite dish, and you see this little thing that comes up off it. You ever see something like that?
Yeah.
So basically what happens is everything that bounces in bounces right to that point. Doesn't matter how it comes in. The curve is designed to reflect everything right to that point. And that's called a parabolic reflector.
So what does it do once it hits that, like?
Well, if this was, let's say this was a dish, you might have a little microphone right there. And that's, if you've ever seen someone, sometimes they use those to hear things far away. Might have an example. Let's see. Let's try typing in parabolic dish. So he's using a, probably just a normal, could be just like a camera with a microphone on it, I'm not sure. But the dish he has on top of it's a parabolic dish. So all the sound that comes in is going to go right to that microphone. So he can hear things very far away. Kind of concentrates the sound. There's a few other examples. So that looks like maybe it's at a football game. Not sure. But all kinds of examples. Yeah.
They have like the same thing, except instead of being a microphone, it's a speaker. And so, like, if you're in a room and there's a lot of them, you can only hear what's going on under that one dome.
Yeah, exactly. Yep. Sometimes you go to like a museum, you see that above an exhibit, because if the exhibit has sound, it can be kind of distracting if the sound is everywhere. So these kind of concentrate the sound. So yep, you could see something like that too.
Isn't this
The
one
gold
like that?
house has the top, so.
Yeah. So yeah, question.
Wasn't there something like one of the buildings in Washington? Isn't there something like that?
In Washington, I'm not sure.
You
Maybe.
could like, it's a whole room and it's full of them, and you could like stand for me and you and yell, but we couldn't hear each other. But if it was like me and somebody outside, we could hear each other.
Yeah. I know there is an example where you. I know they have it at a museum in San Francisco and many other places where there's it's like a huge block of concrete, maybe like 10 feet high. Right? And it's shaped something like that if you look at it from the side. And they make it so basically the focus of this parabola is right about here, about 5-6 feet off the ground, right where somebody would stand. And then there's one on the other side, kind of like this. Right here. And this distance might be 100 feet apart. And you can whisper very softly, and the person standing over here can hear you perfectly because of the way your voice is It's just that reflection. It just directs the sound right to that person. So it's pretty cool. And there's other places that do that too. But it's pretty neat because you can just whisper. And between, like you said, between people can't hear you, but in those two spots, the foci, focuses, they can hear you perfect. It's pretty neat. So there's a lot of different applications for parabolas. But we're mostly going to focus on just the kind of the algebra behind it.
Figure 3.
So in your book, if you look at figure 3, it's on page 379. All that it's saying is this. Okay, we already said this. If you measure the distance from the focus to a point, and then you measure the distance from that point to the directrix, it always comes out the same. So I already worded that, I already explained that to you, and I showed you in the picture right here. Okay, now if you draw a line through your focus, perpendicular to your directrix, that gives you an axis of symmetry. Okay, so let me see if I can just move that off. If I were to draw a line like right there, okay, then that dotted section, that was a line. That would be the axis of symmetry. It's going right through the focus, and it's perpendicular to the directrix. Okay? Cuts the parabola in
So
half.
the directrix is like the DE at top of.
Yep, the directrix is line DE. The parabola never touches the directrix. It bends away from it. And it wraps around the focus. So the parabola wraps around that focus, but bends away from the directrix. Your axis of symmetry, that will touch the parabola. It goes right through it. So if you had a parabola on its side, something like that would be the axis of symmetry. And then the point where that axis of symmetry intersects the parabola, that's called the vertex. And that's your vertex. And then there's one more distance that they measure. Okay, so what I've done in this picture is I drew my parabola, put my focus in, and I measured the distance across the width of the parabola, but I measured it in a certain spot. I measured the width right through the focus. That distance from edge to edge on the parabola, going right through the focus, they call that distance the Latus Rectum. I don't know why. That's just what they call it. So in the book, if they ask you to find the lattice distance, they want you to find the distance from edge to edge on the parabola, going right through the focus. Okay, we'll try one of those today too. Okay, any questions on that? Okay, so that's most of the vocabulary that you're going to need. There's a few other little things, but that's the kind of the major stuff. Okay, next thing I want to look at is, okay, what's the equation of a parabola? Okay, you have four choices for how a parabola can look. This example on the bottom here is opening up. It can open up, it can open down, it can open left or right. That's where the table on page 381 comes in. Okay, we're going to start with the equation y squared equals 4ax. Okay, let's see if we can figure out which way this is opening. If it's up, down, left, or right. All right, so let's see. Remember that your parabola always wraps around the focus. Okay, so if you can remember that, it'll kind of give you a hint of which way it's going to go. Okay, so here's your vertex. It's at 0, 0. And your focus is at a comma 0. A is always a positive number. That's important. A is always positive. So let's just make up an example. Let's say A was, 1. Okay, so we'd have the point 1 comma 0. Okay. That's my vertex. That's my focus. How would this parabola have to open so that it wraps around the focus? To the right. We'd have to look something like that. So this is the equation of a parabola that opens towards the right. Okay, so yeah.
I'm sorry, so that formula always means it opens right?
That specific formula always means it opens right. What controls whether it opens up, down, left, or right? Two things. One, which variable is getting squared? Is it the y or is it the x? That changes something. And then is it a positive 4 or a negative 4? That changes something else. Okay, any question on that formula? And again, that's the first formula. That's in table 1, page 381. Okay, when you graph a parabola, generally you don't need as many points as when you're trying to graph like a sine or cosine wave. Okay, you want to try to find your focus, your vertex, and your directrix. Okay, those are generally 3 things to try to find. And then depending on if the parabola opens up and down, or if it opens left and right, we try to find a couple other points. If the parabola is opening left and right, what I would probably do, try to find a point above and below the focus. If the parabola is opening up or down, then I'd probably try to find points left and right of it. Okay, it just depends which way it's turned. But in general, once you have 3 points, 1, 2, 3, that's enough to reasonably sketch your parabola. Okay, so you need about 3. Any questions on that? So you might see some directions that say discuss the following parabola. When they ask you to discuss it, that means try to find the vertex, the focus, the directrix. Might ask you about the line of symmetry, okay, where that is. That's kind of the main idea. So here's our first example. It says, find an equation of the parabola where the vertex is at the origin and the focus is 3, 0. Okay? First thing I like to do is figure out, looking at this table, which equation do I need to use? There's 4 choices. To figure out which one, figure out if your parabola opens up, down, left, or right. Okay, that'll tell you. So we've got a vertex. Everyone's okay with what's on the right? Okay, let's make that a little bigger. Vertex is at the origin. Focus is 3, 0. Okay, so that's 3 to the right. That's my vertex. That's my focus. Which way is this parabola going to have to open to wrap around the focus? Yeah, it's going to open to the right. We're going to do a nice sketch, so I'm not going to try to estimate it, but it opens right.
Is it the formula for it?
Yep, and that's how I got this. So I figured out it opens right. I looked it up in the table. It says for a parabola it opens right. There's your formula.
So like after you graph it, that's when you can find out what formula it is?
Yeah, after you figure out which way it opens. You don't even have to graph it, just figure out which way it opens. Okay, so now we got that. The only thing we need to find is A. That's what you need. Okay, we got to figure out A. All right, so if we go back and look at our equation. It says right here, if you know the coordinates of the focus, A is the first number. Okay, so let's go back, see if we have the coordinates of focus, whatever the first number is, that's our A. Okay, so let's go back. Okay, so what's A here? 3. So the coordinates of the focus are A, comma 0. In this case, A is 3. Okay, so fill it in for A, and then that's going to be our equation. 4 times 3. And that'll give me what? 12x. Okay, so that's the first part. Find the equation. We've done that. Now, let's graph it. All right, so we got our vertex, we got our focus. We're going to need 2 other points. Okay, try to find 2 more. What would be a good number to pick for x so that we could solve this equation by hand? You could do 1. It would be tough to do by hand, though. Well, 0 we already know. 0, 0. So when x is 0, y is 0. That's the vertex. Anybody? You could do 12. The only reason I'm not is because it's off my graph. I need something smaller.
I was going to say 3.
3. 3 is a good number to pick for x. You can pick anything you want. In this case, remember, the parabola is going to go to the right, so you could not let x be a negative. It doesn't go that way. But let's try 3 and see what happens. Y squared equals 12 times 3. What's 12 times 3? 36. And now what do I have to do to 36? That's why I wanted to use a number 3. Okay? A number that ended up being a perfect square. Square root, square root. And what do you get when you do the square root of 36? Okay, that's partially right. So 6 times 6 is 36. Anything else? There should be another answer here.
-6?
-6, yes. When you take the square root, 6 times 6 is 36. -6 times -6, that's also 36. If you don't have the other answer, you're going to be missing half your parabola. This gives you the top and the bottom. So when x is 3, y is 6. So 3, 6. And when x is 3, y is also -6. That's that symmetry we talked about earlier. Okay, now sketch your parabola. Okay, so that looks good. Vertex is wrapping around the focus. Okay, last thing is let's graph the directrix. So remember, the directrix is a line that the parabola bends away from. Never touches it. So which way is my directrix going to go here? Horizontal or vertical? It's going to go vertical because it's bending away from it. And remember, the distance between a point and the focus and the point and the directrix has to be the same. So let's use the vertex. How far is it between the vertex and the focus? 3. So it has to be 3 between the vertex and the directrix. And that's the line x equals -3. X equals is always a vertical line. Y equals is horizontal. Okay, so that's everything they could ask you to sketch. Vertex, focus, directrix, and the parabola. Yep.
So from the focus, you just go up and down 6?
In this case, yep. And that's also known as the lattice distance. It's the distance between the width of the parabola right through the focus.
What do you mean in this case? Like, if the answer was like different, would it be like up and down like 3?
It could be a different amount. Yeah, in this case, it just happened to be 6.
Would that be 12 or would it be 6?
The lattice distance?
Yeah.
It would be the full distance from top to bottom, or 12 units. Yep, it's 12 units from here up to there.
What happens if it's like
Yeah, if it's not a perfect square, then the answer comes out to a decimal. We just approximate it. Yep. Okay, this one, we don't need to graph. We'll just figure out the vertex, the focus, which way it opens, and the directrix. Okay, so to figure out which way it opens, look at which variable is squared, look at the number in front of x, see if it's positive or negative. Okay, so looking at the y, that's the one that's squared. That means it either opens right or it opens left. Is the number in front of x positive or negative? Positive. If we look in the book, that's the first one, positive number. The one below it is a negative. Okay? So this one opens which way? To the right. Now, what we have here is kind of the final answer, the simplified version. Okay? We have the final. We're going to go back to that step. If I want to know what A is, okay, 4 times something had to give me 12. The something is the A. So let's do the same thing here. 4 times something has to give me 8. So in this case, 2.
And isn't that the first number of the focus?
Yeah, that's my focus. Okay,
Wait,
so
where'd you get the 4?
that's the standard form of the equation.
Oh,
It's always 4 times something and then an x. It's just they had it all combined in the final answer, so it was 4 times 2. Okay, so your focus, that's the first number of the focus. 2, 0.
Is there always going to be a 0 after it?
Is there always going to be a 0? If it hasn't been shifted left, right, or up or down, yes.
Oh.
Yep, we'll look at one that's been shifted, but for now, yep, it's always going to be a 0. Okay, where's your vertex for this kind of equation?
0, 0.
Yeah, if you look at the table, every single one of them, 0, 0. Because we're not shifting it yet.
Is it always going to be like that?
Until we shift it, yes. Yep. And what about the directrix? What does it say the equation is for that?
X equals
It says x equals negative a. So all we have to do is fill in. What did we have for a? 2. So it's x equals negative 2. Right, and that's it. So we found everything they wanted. We don't need to sketch it.
Wait, why is it negative?
That's the formula from the table on page 181, 381. X equals negative a. Yep. We're not going to prove why these are the formulas. We do that in pre-calc, but it gets a little time
I
consuming.
just forgot what the Directrix was.
Yeah.
Sorry.
So don't worry about proving why that's true. We're just going to use the formula.
So
Yeah.
like if we ever get it and it's, I don't know, y squared equals something that's not 4, is it always going to be a multiple of 4, or?
Most of the ones I give you, yeah. Yeah. You could have one that's not, but we'll stick with ones that mostly are. Okay, let's look at this one. Figure out which letter is squared. Figure out if you have a positive or negative in front of the variable on the other side, and that'll tell us which way it opens. So x is squared, the number in front of y is a negative. Which way is this parabola going to open?
Down.
Yeah, if you look at the table, this one opens down. Yep. When x is squared and the number in front of y is negative, opens down. What letter do we need to figure out the focus? We need A. So remember what I said earlier about A. It's always positive. Always positive. So the only way you could get a negative here is if it was like this. If the 4 had the negative. So we got to figure out what A would be.
Why is it an X? Does that mean it's not like up or down in opposite? So like,
Yeah, when x is squared, that means the parabola is either going to look like this or like that. When y is squared, it either looks like this or like that.
I don't get why it opens down.
It opens down because x is the variable that's squared and the number in front of y is negative. So that's the last equation in table 1.
Well, yeah, but in that one it says 0 negative
Yep, so that's the formula for your focus. When we find the focus in a second, we're going to use 0, comma, negative a. So your formula for your focus and your directrix, they change depending on which equation you're using. That's why we just look at the table. All right, so we know it opens down. What did somebody say? What was a here? 3. Okay, that's a. So now the focus. Let's look up the formula. It says use 0, negative a. Okay, so what's my focus going to be?
so it's switched around.
Yep, it does switch around. Yep. 0, negative 3. So before we had a 0 for y. Now we got a 0 for x. It's because the parabola was been turned a different way. Okay, what's it say to use for the directrix? What's the equation there? Y equals a. Okay, so in this case, it's y equals what? 3. And the last one is the vertex. Okay, looking at that table, what does it say to use for your vertex? 0, 0. Yep. Okay, and yeah, since I have a grid, let's graph it. So my focus is 0, negative 3. Vertex 0, 0. Remember, it has to wrap around the focus, so it's got to open down. That makes sense. That's exactly what we had. And let's take the equation. What kind of values do we have to pick for y if it's going to open down? Yeah, we got to pick negatives. If you pick a positive, it won't work because the parabola doesn't go up; it goes down. Anybody see a good value for y? What is it? Someone said? Yeah, I would do negative 3. It's actually going to work out very similar to the last problem. I'm just picking negative 3 because the answer will come out nice. So x squared equals negative 12 times negative 3. Negative times negative is a positive 36. So what's x? Anything else? Positive or negative. Remember, that's what gives you the symmetry, both halves. Okay, so when y is negative 3, we're at 6. So when y is negative 3, we're at 6. And when y is at negative 3, we're also at negative 6. So negative 3, negative 6. And there's your parabola. And remember that focus, that's the point where if this was like a mirror or a microphone, all those sound waves or light waves, they're all reflected right to that point, the focus. Hey, any question on that one? Okay, so let's try to find an equation of the parabola. The focus is at 0, 4, and the directrix is at y equals negative 4. Okay, so here's my focus. I'm going to go up 4. And my directrix is a horizontal line at negative 4. Does the parabola bend towards the focus or away from it? Look at that picture. So DE is your directrix. Is the parabola bending towards it or away from it?
Away.
Away, yeah. It's never going to touch the directrix. If it does, then something's wrong. So there's your, let's see, 1, 2, 3. Yep, there's your directrix. So knowing that we have to bend away from it, which way does my parabola have to open? Up. It's got to open up. Okay, and we know the vertex is at 0, 0 because we haven't done any other type yet. Okay, what's the equation of, let's see, a parabola that opens up?
X squared equals
Yeah. Equals,
4, positive 4.
yeah, it's a positive 4, then AY. Okay? So now if you look in that same row, your focus, what's the formula for the focus? 0, comma, A. So A is the second number. Okay? So we've got A. Plug it in, and that's it. That'll give us our answer. So what's the equation here? X squared equals 16y. X squared equals 16y. We don't have to graph it. There's our equation. Questions on that? Okay, let's try one more before we
Wait, so
look at the shifts. Yeah.
in the last one, which number of the focus do we use? Do we use the X or the Y?
If you want A, in that case, it's the second number.
Oh,
Yep. Again, just go by that table
what's the-
on page 181, 381. All right. See if we can figure out the formula here. What's the first thing I said you need to know to figure out the formula?
The focus and reverse.
Okay, if we don't have the focus here, so what else can tell me it's one of 4 choices? I got to know what about the parabola. Yeah, which way it's directed. Is it up, down, left, or right? If you can figure that out, then you can figure out, then we can get the formula, then we can find everything else. So we have a vertex at 0, 0, and it contains the point -1/2, 2. This isn't a special point. It's not a focus. It's not a vertex. It's just a coordinate somewhere on the parabola. So -1/2 up 2. Which way does this parabola have to open? Why? Why can't it open right?
The negative half.
Yeah, we'd never go through that point if it opened right. It'd never go through the coordinate. Okay, so it's got to open to the left. And the other reason you know that it opens left is your axis of symmetry is horizontal. Okay? If you're going to cut something in half and have it be symmetrical horizontal, it either opens this way or that way. If you're gonna, you're gonna cut it in half, it's got to open left or right if the axis of symmetry is horizontal. Okay, so it's X and Y. Okay, so it opens left. Okay, we don't need a sketch. That's just to help us get the equation. Okay, equation when it opens left, y squared equals -4ax. Now the problem is we usually get A by looking at the focus. We don't have the focus. But what else have they given me? Okay, they gave me the line of symmetry as the x-axis. Anything else? Yeah?
They gave us the half, which is the extra 2 points we need.
Yep, what's the -1/2? What is that?
Like, we have a point in the middle of the parabola and the 2 points on the sides. I think it's 1 points on the sides. I don't remember that's all.
Is it a certain letter though, the -1/2? It's not the A because we don't have the focus. But it's just a generic coordinate.
X.
It's an X. What about the 2?
Y.
It's a Y. So we know X And we know y. Can we find a? Yeah. Just fill in x and y, and then we can find a that way. Okay. So we're going to have 2 squared.
Would those 2 points be what?
Those 2 points, what?
And when you plug those numbers in, what does it do?
When we plug them in, it's going to solve for a.
Oh.
So we know x, we know y, we're going to find a. So 2 squared gives me 4. What's a negative times a negative? Positive. What's half of 4?
2.
2. So what would a be here? 2. Yeah. Okay, so a is 2. Now you can write your final answer, just filling in for a. It's kind of like when you write your final answer with y equals mx plus b. You never fill in for x and y, just everything that's not x and y. So your final answer is y squared equals, what's negative 4 times 2? Negative 8x. And that's it. You don't have to do a detailed sketch, just the equation. Okay. Any question on that one? All right. So this is the table that's in your book on page 383. So you don't need to copy that all down. It's all in your book. But if you're going to put a table on the test, this is the table I would use. Because this table will do everything we just did in the last examples. And it also takes care of if the vertex is not at 0, 0. What if it's shifted? Okay, well, if we shift the vertex, the horizontal part, the x, we call that h. And then the vertical part, that's k. Right? So hk would be where your vertex is shifted to. A is still the same. A is the distance from the focus to the vertex. Always. A is always the distance from the focus to the vertex. Okay, this table summarizes each case very, very nicely if it opens right, left, up, or down. So it tells you your equation you're going to use, tells you the formula to find the directrix, formulas for the focus, and the vertex. Okay, so again, it's on page 383. So now there's 3 letters you need to find to do this. You need H, you need K, and you need A. Those are the 3. Let's try an example. And we'll go back to that table, or you can just look at it in your book. Okay, it says the vertex is negative 2, 3, and the focus is 0, 3. Find the equation of the parabola. Okay, what are the 3 letters I need again? Let's just write those down. Yep. H, K, and A. Are there any letters there that we know right away? Okay, so let's look. A. A is the distance between the focus and the vertex. How far apart are those points, the focus and the vertex? Yeah, they're 2 units apart. So you have your vertex, left 2, up 3. And then your focus is just up 3. They're 2 units apart. Okay? So that's A. A is 2. Anything else that we know? Just based on what we were given. What else? No, we do. We know H and K without any work. It's the vertex. The vertex is H, comma K. So what's H here? And K? 3. So now we've got everything we need We just need to figure out which one of these four formulas do we use. Are we opening up, down, left, or right? Which way am I going to open here? Yeah, I'm going to open towards the right. I got to wrap around the focus. My directrix would be over there. Be 2 units to the left of the vertex, just like the focus is 2 units to the right. All right, so let's look up the formula when we open right. Opening right, y minus k squared equals 4a times x minus h. And now just fill in h, k, and a, and then you're done. So let's start with k. So it's y minus k, which is 3. 4 times a, that will give me how much? 8. And what am I going to put in parentheses? What's x minus h? How would you write that here?
Wait,
Why is it going to be x plus 2? Yes.
Minus, minus.
Right. It's x minus 2. So when you have minus a minus, it becomes plus. So you also have to be careful if I gave you a formula like this and I asked you, what's h and what's k here? Well, be careful. H must have been a negative. That's why this came out positive. Right? And k is positive 3. Okay, and that's it. That's your equation. Okay, any question on that? Yeah?
what are those like, the H, the K, and the A?
The h and the k?
Yeah.
The h and the k come directly from the vertex.
Oh, is that when it doesn't equal 0, 0?
That's when it's not 0, 0. Yep. So if your vertex isn't 0, 0, then you're using one of these 4 formulas right here. All right. What else did they want? Anything? Let's see. That's it. Just find the equation. So we're done. Okay. Any questions on that? Let's try another one in a second, but just to kind of summarize what we've had so far, you might have noticed the pattern that all the equations of parabolas involve 2 variables, x and y. So they all have 2 variables. One of the variables is squared. The other one is linear. That's when you get a parabola shape. So one of the variables has an exponent of 2, the other one doesn't. If both variables have an exponent of 2, then we can get into either a circle, an ellipse, or a hyperbola. Depends. Depends on other factors. But parabola is the easy one to pick out because one variable is squared, the other one isn't. So sometimes they give us an equation and we need to complete the square before we can discuss it. So if you look at the equation we have on the left here, y minus 3 squared, you never want to do that out. This is what you don't want to do. Write it as y squared minus 6y plus 9. Okay, what I did is I FOILed it out and I distributed the 8. And then sometime what they'll do is they'll move everything to one side. Like y squared minus 6y minus 8x and then minus 16. This is still the same equation as we had up above. It's just this version is awful to work with because it's not written. Let me make it bigger. It's not written the way we need it to use the table. So we never, smaller. never want to FOIL that out and do it out. In fact, if it is FOILed out, I just explained, we're going to have to reverse that. Okay, we're going to have to complete the square. Okay, to get it back the way it was. Okay, anybody remember doing that from Algebra 2, completing the square? A couple people? Okay. So we'll go through an example. I'm not really going to teach a whole lesson on it. Hopefully people remember it. But we'll see. And so here's an equation that's a parabola. Problem is we can't discuss it. It doesn't match up with any of the ones in the table. So we're going to complete the square. Okay, first thing you want to do when you complete the square with a parabola is keep all the x's on one side, and then we'll put all the y terms on the other side. Okay, the reason? That's how every one of these formulas looks. All the x's on one side, y's on the other. Yeah, so let's just start by separating. Okay, how would you move negative 4y to the other side? Yep, add it. Okay, now the next thing you're going to do is complete the square. When you complete the square, you're adding a number to both sides. As long as you add the same thing to both sides, that's fine. You just got to do the same thing everywhere. Does anybody remember how you figure out what number to add to both sides? That's completing the square. Okay, so the way you do it, take half of the number in front of the linear term. So in this case, it's a 4. 4 in front of x. So take half of the coefficient of the linear term. Square it. And that's the number you add to both sides. Okay, now that assumes something, which is happening here. That assumes that the coefficient of x squared is a 1. I'm just going to abbreviate it. Coefficient of x squared is 1. And in this case, it is. If it's not, I'll show you in the next problem how that works. Okay. So let's do what it says. Take half of the coefficient of the linear term and then square it. Okay, so what's half of 4? 2. Now square it. 4, and add that to both sides. Whatever you do to the left, you have to do to the right. Plus 4, plus 4. Now, if you've completed the square correctly, that left side should factor very nicely. Okay, on the other side, just leave it like this for now. What will that left side factor into? Should factor into two things that are the same. They'll be identical. So what do I put here? A what? Plus in here? A plus 2. Okay, if you complete the square correctly, that's going to happen every time. X plus 2, x plus 2. Now, instead of writing it as x plus 2 times itself, let's use our shortcut. That's x plus 2 squared. Now we're getting something that looks more like the formulas in the table. Okay. What about on the right-hand side? Anything in common between 4y and 4? Yep, so take the 4 out. Now we finally have an equation that matches up with something in the table. Let's see if we can figure out which one it is. X is the one that's squared, and the number on the other side is a positive. So let me put up the table if you don't have it. x is the one that's squared, and the number on the other side is positive. Which way is that open? Yep. X is squared, 4 is positive. It opens up. Okay, so that's our first question. Opens up. Okay, let's get the formula for the vertex. To find your vertex, it's h comma k. So at this point, maybe we should make sure we can figure out what's h, what's k, and we're going to need a. Okay, so let's look at that equation. H, k, and a. Okay, what is h? Not 2. Be careful because of this plus sign here. Yeah, it would have had to have been a -2, and that's how it would have become a positive there. Because it's x minus h. So x minus -2.
Wait, why is that H?
H, let's look at your formula. So h always goes with x, and k always goes with y. So h is always what comes right after the minus sign with x, and k comes right after the minus sign with y. That's why if it's a plus sign right there or here, I said be careful. So that changes the sign of your number. What about k? Yep, k is -1. And now a, well, let's figure out what a is. So we have, well, actually, we're doing the one above it, sorry. 4 times something has to give me, what number did we have there? Yeah, 1. So we had a 4, so 4 times 1 gives me 4. So a is 1. Okay, if a was anything else, I wouldn't have a 4 in front. Like if a was 2, we'd have an 8. Okay, but we had a 4. So that makes a 1. Okay, vertex is always h comma k. There's your vertex. Okay, focus. Let's get the focus. Focus is h comma k plus a. So just fill in the numbers. H comma k plus a. So we get -2 comma, what's k plus a?
0.
0. Yep. And lastly, look up your formula for the directrix. Okay, directrix, y equals k minus a. Okay, what's k? -1, good. Okay, what's a? 1. So what's -1 minus 1? -2. Not -1 plus 1, that would be 0. Okay, so once you complete the square and you get your equation the way it should look, h, k, and a are easy to find. But the way they gave me this problem originally, we can't work with it. Okay, so you have to complete the square. Okay, any question on that? Okay, so for our last one, we won't do a parabola. Let's just practice just a pure algebra problem, how you complete the square. That's all we'll do. Okay, remember last time, first thing I said to do was move that 4y to the other side. Okay. Anything that doesn't have your variable that's being squared, put that on the other side. So in this case, that's my 4. Everything else has an x. What did I say the coefficient of x squared had to be? If you're going to complete the square, can it be a 3? It has to be a 1. Okay, we assumed last time the coefficient of x squared was a 1, and it was. Okay, but this time it's not a 1. So what do 3 and 12 have in common? A 3. So what we're going to do is factor it out. 3 times what would give me 12x? Yep. I left a little bit of space because now I'm going to complete the square. I'm going to add something to both sides. Yeah, we're going to add the 4. So take half of this term and then square it. You don't always get back what you started with. Like if you took 6, half of 6 is 3, squared is 9. It just happens with a 4, when you take half of it, you get 2, and then you square it, you get a 4. So what am I going to add on the right? If we add a 4 on the right, we're not adding the same thing on each side. Anybody see why? No, it is a positive 4 inside parentheses. Yep, the negative 4 is just what was there from the beginning of the problem, so that's fine.
We rooted the 3 out.
We factored out this 3. So this isn't really a 4 if you did out what's on the left. What is that? It's really a 12. That's what always trips people up. Think of that 3 as being distributed. You really added a 4 times 3. Okay. And now let's factor the other side. Okay. This is going to factor as we just did this. What's x squared plus 4x plus 4 factor as? X plus 2 squared. And we're done. Again, that wasn't a parabola problem. We're just practicing completing the square. So that's what you have to do if it's not a coefficient of 1. Okay. So tomorrow we'll look at ellipses. I think those are a little bit easier than parabolas. We started, I think, with one of the toughest ones, and they'll get a little easier. Okay, so the homework on 386 is 11 to 18 all. 19 to 29, 37 to 41, just the odds. Those are time consuming, so don't do all, just the odds on those. And 47. I think 11 to 18 is matching, so that's pretty quick. Okay, so we'll take a look at that tomorrow.